अपनी स्क्रीन शेयरिंग बंद कर दी? ठीक है। हाँ।
Hatvet Pharma Private Limited is a pharmaceutical company with its head office at Meerut. It was founded on 29 January 2019 with a vision to provide affordable and quality veterinary medicine to our pet parents. Hatvet Pharma is doing marketing of veterinary pharmaceuticals throughout India. In a small span of 1 year, we have launched 51 products in the veterinary pharma industry to serve our clients. In future 1 year, we are planning to have a product basket of more than 100 products. Hatvet is different from other veterinary pharma companies as we don't have distribution channel. We understand the latest needs of market, and for this reason we have adapted to online module of selling our drugs to field practitioners. We are serving our clients by providing the required medicines at their doorstep without any middleman. We directly collect orders online, mobile app, WhatsApp, telephonic from our end customers, and we deliver the required products to their doorstep through our nationwide logistic partners Blue Dart, DTDC, TCI Express. We are happy to announce that in our client list, most of the leading pet practitioners of India are included. To assure the unbreakable faith of our clients in our company products, we look after the quality of products, starting from selecting the raw material for our final products, aseptic precautions during manufacturing, and proper storage of finished products till supply to the end customers to ensure quality of products. We are happy to share that Hatvet Pharma has been recognized at various business platforms. Recently, an article on Hatvet Pharma has been published in the leading business magazine Business Connect. One more milestone in the success story for Hatvet Pharma is that the managing director of the company, Dr. Rajneesh Tyagi, has been awarded Young Asian Entrepreneurs Award at Bangkok, Thailand on 7 February 2020. Our vision states Hatvet Pharma to be a commercially viable leading veterinary pharmaceutical company in providing quality products affordable to various sections of the pet owner society. Our endeavor is to be a front runner in innovation and quality in the veterinary pharma industry. We see a very bright future for our company as we are working in pet industry, which itself is growing at a higher rate, approximate growth of 20% annually. We are regularly working on the knowing of needs of our customers to serve them in a better way. We value your support to Hatvet Pharma and are very thankful to all of you. We look forward for a very strong and long business association between veterinarians and Hatvet Pharma. Thank you.
ठीक है. Good afternoon, colleagues. I'm Dr. Rajneesh Tyagi, Managing Director, Hatvet Pharma. First of all, I welcome all participants who have joined us in today's session at Zoom app and those who have joined us in the live streaming of this session at YouTube channel of Hatvet Pharma. Today is the third session in the series of 4 webinars on small animal laboratory interpretations. Now, I want to thank Dr. Dayaram Suryavanshi for accepting my request to become guest speaker for this series, and I hope you all will enjoy his knowledge and command on small animal pathology. At present, Dr. Suryavanshi is the director at Omega Laboratories and is my senior from Bombay Veterinary College. Dr. Suryavanshi has an experience of 22 years of clinical pathology. Dr. Suryavanshi has brilliant academic and teaching records, and he is the recipient of various awards like Best Teacher Award, Best Worker Award, Best Researchers Award, Young Scientist Award, and many more in the list. Now, I want to give you a small introduction of Hatvet Pharma and how you people can grow your business with Hatvet Pharma. In January 2019, I entered in veterinary pharma business and laid foundation of Hatvet Pharma Private Limited with a vision of affordable and quality medicines for our pets. Since then, we have successfully launched 63 products for our pets and many new products are in the pipeline. At present, we are doing business throughout India with the valuable support of our pet practitioner friends. Hatvet Pharma is a company for veterinarian only, means we bill our products to veterinarian only, and our products are not available in the open market. We don't have distributor channel or marketing field staff. We operate on online module. The order for our goods can be placed online at our portal, which is www.hatvet.com, or by WhatsApp to my number or company office number. The order goods will be supplied to your doorstep by our nationwide logistic partners like Blue Dart, TTDC, and TCI Express. The payment against supply goods to the company can be done through online transfer or by Paytm. We will be happy to have business association with you all, so please prescribe or dispense products of Hatvet Pharma. And now, one important announcement to all participants. Due to some technical reasons, video of Dr. Suryavanshi sir is not working, so please bear us. Dr. Suryavanshi will be giving lecture, but maybe his video is not will be visible to us, but screen will be visible. He will be visible for questions and answer. You can type your question and answer in question answer box, and all your answer will be answered in the last of session. So now I take a leave and request Dr. Suryavanshi sir to start the session. And thanks again for joining us today. Thank you. Dr. Suryavanshi sir, please.
Yeah, thank you, Rajnish.
So slightly volume.
Okay. Are you getting?
Yeah. Yeah.
Yeah, no problem.
Now you can share screen. Yes, sir.
Yes. Hello, good afternoon, friends. And thank you, Dr. Rajnish, for giving opportunity to interact with you people. And today's our topic is a canine urine analysis and its interpretation. Many times during our regular pet practice, we are not looking seriously towards the urine analysis and examination of urine. So today we are discussing the same thing, and so many things we are going to discuss. As Rajnish told, the Omega Laboratories since last 14 years working in the field, and up till now, the more than 3 lakhs blood sample has been examined, more than 13,500 postmortems has been covered, and we have collaboration with many national, international, multinational companies, and we are conducting clinical trials for them also. Okay, now starting towards today's topic, urine examination. The first thing is that we should find the different indications of urine analysis. Now, there are complaints by the many pet owners that their dog is showing polyuria, oliguria, sometimes anuria, maybe offensive, maybe more ammonical. Then the changes in color of urine may be dark color, maybe reddish, maybe cloudy. Then the clinician's point of view when we have to collect and when we have to go for the urine analysis. Now, depending upon the history of the suspected renal diseases, we can collect the urine and examine the urine. Then whenever there is a lower tract infection, in that case also we have to collect the urine. Then to find out the prognosis of the case of the dog or pets, we are going to collect the urine samples. Then sometimes there is a systemic reaction, and maybe due to the secondary effect due to the cardiac insufficiency or the hypoperfusion to the kidney. In that case also we have to go for the urine analysis and urine examination. Then secondary effects of the systemic reaction like antigen antibody reactions, febrile conditions, means fever is there whenever there is a dehydration by so many things. Then other organ dysfunctions like liver dysfunction. In all these conditions, these are the indications for the collection of urine and examination of urine. Now, like CBC, we know the CBC, the complete blood count. In the same fashion, there is a CUA, that complete urine analysis. The complete urine analysis is a term generally used for the analysis of the urine of the pet animals. Then this includes the physical examination, chemical examination, then microscopic examination, and the microbiological examination. Now, all these four examinations are most important for the identification of the kidney diseases, as well as to find out the prognostic values of the patients. And for this purpose, we are going to examine physically, chemically, microscopically, and whenever it is required, we can go for the microbiology, that is the culture and sensitivity. So we can give the specific treatment for the pets. Now, collection of urine. So collection of urine can be collected, or urine can be collected by direct. Whenever the pets are urinating, the owners can collect the urine. If pet come to the our clinics, in that case, we can go for the catheterization. So we can use the catheter for the removal of urine, and sometimes we can go by the synthesis. The cystosynthesis can be done with the due precautions with the sterile syringe, and we can collect the urine. Then what to do with that urine? So specifically the fresh urine should be examined. That is the rule. So after standing, so many changes may occur. The preservative may interfere with the chemical analysis. So it's better go for the fresh urine examination. Then if the urine has been collected early in the morning, that will be the best sample for the examination of the urine. Now, the flushing of urethra, prepuce, vulva to avoid the contaminants. So whenever we are going for the catheter, we are using the catheter. In that case, we have to flush the urethra, flush the prepuce, vulva to avoid the contamination. Then sterile and clean containers should be used. So for the collection of urine, the and clean containers should be used to avoid the secondary bacterial component. As soon as possible, it can be examined freshly lab. So ideally we should go for the fresh urine analysis. Now, whenever we are keeping urine for the longer period, after some time, ammonia on the storage, it get converted into the urea is get converted into ammonia, and the acidic urine may become alkaline. So the pH of urine can be changed because of the preservation. In the preservation, the urea is get converted into ammonia, and finally we are not getting the exact result. Then after storage, some of the bacteria can grow frequently in the urine, and they can do the same thing. They convert urea into ammonia. Then some of the cellular elements get dissolved in the alkaline environment. So say for example, hyaline cast are there. The hyaline cast may get dissolved and we are not getting the correct interpretation. So within 2 to 3 hours, we can store for the 2 to 3 hours, we can store the urine at refrigerator, but we don't have to go for the freeze, deep freeze. So the below 0 degrees centigrade, we should not keep the urine. Then the all cellular details get lost. When we go for the freezing of the urine, the all cellular details get lost. Now, so when we are keeping samples at the refrigerator, so after that, we should bring that sample to the room temperature, normal room temperature, especially for the specific gravity. If we want the specific gravity, accurate specific gravity, in that case, we should not use the chilled urine for the demonstration or the interpretation of the specific gravity. So first we have to bring that sample to the room temperature and then go for the specific gravity evaluation. Then some of the changes, enzymatic changes can be observed because of the storage. So for these things, the preservation of urine is essential, and as the rule, we should not deep freeze or freeze the urine. We can keep the urine for 2 to 3 hours in refrigerator, and then we can go for the examination. Now, some of the preservatives and their interference with the interpretation. So many times the toluene has been used, thymol has been used, and the formalin generally used for the preservation of the urine. Now, each and every preservative is having its own disadvantage. Now, if we are using the toluene, it will affect the glucose and ketone interpretation. If the thymol is added, the false positive, false negative reactions may be occur because of the thymol. Then formalin is interfere with the glucose, so the false positive reaction may observe because of the formalin. Generally, we are not using, or not generally, so we are not using any preservative for the culture. Whenever we want to go for the culture and sensitivity, in that case, we should go for the direct sterile urine, carry in the cold chain and go for the culture sensitivities. Boric acid generally used for the hormone analysis. Whenever we want to examine some hormones like progesterone, in that case, boric acid can be used as a preservative for the carrying the urine from the place to the laboratory. Now, starting with the physical examination of the urine. So physical examination of urine includes the volume, the color, transparency, specific gravity, smell and odor, smell or odor. So starting with the volume. So generally dog volume is vary from 0.5 to 2 liters, and the ml per kg body weight, the production of urine is 25 to 41 ml per kg body weight. In cat, it's variable volume, but ml per kg body weight will be 22 to 30 ml per kg body weight. So this is the volume. So this volume generally has been calculated for the collection of urine for 24 hours. So 24 hours we have to collect the urine, then go for the final volume of that particular animal. Now volume and its interpretation. Now the volume may be increased, may be decreased. So the things which increase the volume, so polyuria, it may be sometime it is a transient. So transient may be due to the more water consumption, then more diuresis, then excess of intravenous fluid has been given, and sometimes whenever dogs eat the salty foods, and that will increase the thirst, and whenever there is an increased thirst, there are chances of taking more water by the pet, and finally the polyuria may be the resulted. Then corticosteroids, use of corticosteroids may lead to the transient increase in the volume of the urine. Then pathological alterations. So whenever there is an increased volume by some of the pathological conditions, so early stage of progressive renal failure, then tubular diseases, ischemia, then diabetic insipidus, diabetes mellitus, then selective glucose reabsorption disorders, and renal amyloidosis. So in all these conditions, there may be the chances of increase in the volume of the urine. Now we will see the different factors which are responsible for the decrease in the volume of urine. So transient may be due to the decreased water intake, the high environmental temperatures. So in that case, due to the panting, there is a loss of water. Then exercise, sometimes exercise also lead to the wastage of water or the evaporation of water. Then dehydration may be due to the vomiting and diarrhea. In all these conditions, the transient or physiological changes can be observed that may lead to the oliguria. Then pathological conditions, whenever there is a fever, the acute renal failure, chronic renal failures, the less volume, low specific gravity. Then the in chronic renal failures, there is a less volume and a low specific gravity. Now, whenever there is a low blood pressure, whenever there is any kind of cardiac disease, in that case, there is a hypoperfusion to the kidney, and that may lead to the low volume or the less volume. Then sometimes ascites or circulatory disturbances and congestive conditions in the abdominal cavity, that may lead to the oliguria in the pets animal. So these are the conditions. In that case, we are getting the less amount or the less volume of the urine which has been filtered to the kidney. Now color. So normal color of urine is a straw to yellow umber color. It's normal. Now colorless to pale urine, it can be observed because of the excessive dilution, then excess intake of water. Then it can be observed in the end stage renal diseases, diabetes insipidus and diabetes mellitus. Then dark color urine, dark yellow to yellow brown color urine. It is a concentrated type of urine and with having this little bit higher specific gravity. Then it can be observed in the acute nephritis, less fluid intake, prolonged vomiting and diarrhea, and the prolonged fever. So in that case, the dark yellow to yellow brown color urine can be observed. Red urine, wine color urine, or brown color urine can be observed in case of the hematuria and hemoglobinuria. Then brownish to black color urine, it can be observed because of the excess of the bilirubin in the urine. Then hemoglobinuria, sometimes myoglobinuria, methemoglobin, carbolic acid poisoning. In that case, there are chances of the changes color of urine from brownish to black color. Then milky color can be used. Milky urine can be observed in case of the crystalluria and suppurative cystitis. Then green color can be observed because of the biliverdin, methylene blue, and pseudomonas infection. So these are the changes that can be observed in the urine in the different conditions of the pet animals. The transparency, the color clear can be observed in a fresh urine. The urine should be fresh in normal healthy dogs. It may be cloudy due to the cellular components. That cellular components may be epithelial cells, leukocytes, red cells, and mucus. Then flocculent, it can be observed because of the crystals and cellular components, but it gets settled down after some time. So the flocculent urine, it contains some of the cellular material and crystals, but cloudy remain because of there is a mixture of epithelial cells and mucus together. Now, the cloudiness always not pathological unless it's correlate with the microscopic examination. Just looking towards the cloudy urine, we can't say that this is because of some pathological conditions. So in that case, we must correlate the cloudiness of the urine along with the microscopic examination, and it's better again we have to correlate with the creatinine and blood urea nitrogen together. Now specific gravity, the another physical examination of the urine that includes the physical specific gravity of the urine. So the normal specific gravity ranges from 1.015 to 1.045. That is, it's normal. Now decrease in a specific gravity and increase in a specific gravity can be observed in a variety of the conditions. Now the animals, it is generally we are following some thumb rules. So animals that produce a large volume of urine are expected to have low urine specific gravity, whereas animals that produce a very small volume of urine are expected to have a high specific gravity. So this is general rule we are following, but there is an important exception to this general rule in the animal with oliguria and acute intrarenal failure that has a low urine volume and low specific gravity. So these things should not be overwhelmed, and we should follow during the examination of the urine. Now, decreased specific gravity can be observed because of the lack of ADH, then resistant to ADH, then increased water consumption, the primary polydipsia, then lack of medullary concentrating ability. So, medulla of the kidney are able to concentrate to filtrate. So, if that ability is get lost, in that case, there is a decrease in the specific gravity of the urine. Now, increase in the specific gravity of urine. So, the elevated specific gravity must be interpreted with the high blood urea nitrogen. So, blood urea nitrogen must be high, creatinine concentration should be high, and the hydration status. So, all these things should be considered together. Then, high specific gravity does not rule out this presence of some specific disease. So, just only observing the specific gravity, we can't say that the animal is suffering from the specific renal disease. So, in that case, we should follow the same thing, the blood urea nitrogen, creatinine concentration, and hydration status of the animal. Now, some associated diseases are also to be ruled out along with the urine examination. So, hepatic insufficiency, hyperadrenocortism, and hyperthyroidism. In these three things can also interfere with the specific gravity of the pet animals. Now, after that, we should go for the chemical analysis of the urine. So, first thing is the protein, pH, then protein, blood occult, then glucose, bilirubin, and ketone. So, these are the general things generally followed in the laboratories. So, many times we are using some strips or some pads are used, some chromatological pads, some strips. Simply the strips are used for the demonstration of these things, but for the demonstration of the specific gravity, these tips generally should not be used. So, because of the chroma and the interference of the so many things, so it is better go for the urinometer for the identification of the specific gravity. But the pH, proteins, occults, then the glucose, bilirubin, then ketones, they can be perfectly used with that particular strips, or the ready-made strips are available for the identification of different kinds of the chemicals which are present into the urine. Now, starting with the pH, the pH, the normal pH is 6 to 7. Now, sometimes the pH may become acidic, more acidic. So, more acidic pH can be observed based on the meat-based diet. If the dogs has been provided only the meat-based diet, in that case, there are chances of the more acidic pH of the urine. Then, administration of the acidifying agent. Sometimes the acidifying agents may be the decrease the pH of the urine. So, in that case, the acidic pH may be observed. Then, metabolic acidosis, respiratory acidosis, then paradoxal aciduria in metabolic alkalosis with the hypokalemia, then chlorine depletion, and protein catabolic status. So, whenever there is a protein catabolism, excess of protein catabolism that observed in the body, then whenever the dog has been kept on the meat-based diet, in all these conditions, there are chances of the acidic urine, more acidic urine. Generally, in canines, the urine is acidic, but it can become more acidic because of all these factors, and we should consider all these factors while while interpreting the results. Now, alkaline urine. So, whenever there is a vegetable-based diet, so like human beings, again some of the pets has been kept on the vegetable diets. In that case, there are chances of the alkaline pH of the urine. Then administration of the alkalizing agent, so sodium bicarbonate, then citrate sometimes. So there are chances of the changes in the alkalinity of the urine. Then metabolic alkalosis, respiratory alkalosis, urinary tract infections, and the urease positive organisms. Whenever there is a cystitis, and cystitis may be occur because of the urease positive organism. In that case, there are chances of the more alkalinity in the urine. Then post pregnal alkaline tide, then distal renal tubular acidosis. So in that case, there are precipitation and may lead to the alkalosis. Then urine allowed to stand to open air at room temperature. Whenever there is a we are kept on the We +1, +2, +3, +4 the urine. Now traces less than 10 milligram per dl. 30 milligram per dl of the protein present into the urine, +2 the 100 milligram, +3 300, +4 it's around 400, it's around 1000 milligram per dl. So these are the gradations given depending upon the concentration of proteins which is dissolved into the urine, +1, +2, +3, +4. Then false positive results may occur in alkaline urine. So
Hello, Dr. Suryavanshi. Hello. 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 Kindly wait. I think Dr. Suryavanshi connection has been disconnected. We will be joining soon. Yeah, due to some technical reason, Dr. Suryavanshi connection has been disabled. He will be joining soon. That's why no audio is available. Please bear us. Kindly wait. Yes. Dr. Suryavanshi, can you hear me?
yeah.
Please start your connection with this.
Yeah. I started. Should get.
Yes, I start from this on this slide protein from initial.
Yes.
Because it is disconnected earlier.
Okay. Is it okay now?
Yeah.
Okay. Chal. Okay. So protein analysis. So again, I will start with this protein. So on routine analysis, the protein concentration can be reported based on this trace, then the +1, +2, +3, and +4. So +1 is the 30 milligram per dl, +2 100 milligram per dl, then +3 300 milligram, and +4 more than 1000 milligram per dl. Now false positive and false negative reaction can be observed. The false positive reaction may be observed because of the alkaline urine, then use of some compounds, ammonium compounds, which can interfere with the protein, and false positive reaction may be observed. Then false negative reaction can be observed because of the urine that is acidic or more diluted. So more diluted urine also show the false negative reaction. Now causes of the renal proteinuria or the pathological causes of the proteinuria, increase glomerular filtration of the protein, then failure of tubular reabsorption of protein, then tubular secretion protein. There is a increased tubular secretion of the proteins, the protein leakage from the damaged tubular cells, renal parenchymal inflammation, and combination of all above. So increase glomerular filtration of the protein. So whenever there are damage to the basement membrane of the Bowman's capsule, there are chances of the leakage of proteins, then failure of reabsorption. Some of the proteins get reabsorbed from the nephrons, and sometimes it get leaked, and that lead to the proteinuria. Then tubular secretions of protein. Whenever there is a secretion of excess of protein from the tubules, so the tubules are secreting proteins. So whenever there is an increased chances of the proteins, excess secretion of proteins, that may lead to the pathological proteinuria. Then protein leakage from the damaged tubular cells. Whenever there are so many toxins, so many infections, so many toxemias that lead to the damage to the tubular epithelial cells. And finally, the ultimate result of that is the proteinuria. Then renal parenchymal inflammation. Whenever there is inflammation, so many bacteria, so many viruses, protozoas, they may lead to the inflammatory reactions, then antigen antibody reactions. So all these factors will lead to the renal parenchymal inflammation, and ultimately all these conditions may lead to the pathological renal proteinuria. So after that, the blood occults, the false positive reaction may be observed in the urine with the contamination with the bleach, the sodium hypochlorite, the bleaching powder simply. Whenever the bleaching powder is there, we are getting the false positive reaction for the blood occults. If the urine contains large amount of the iodide or bromide, whenever there is a excess of iodide or bromide, in that case also false positive reaction may be observed, because we are using the nitroprusside pad. Whatever the pad is there for the identification of blood occludes is a nitroprusside. So the nitroprusside is mixed with the, or the combined with this sodium hypochlorite or bromide, that may lead to the false positive reaction. The false negative reaction may result into the urine whenever there is a mixing of the urine. The negative results may occur if the urine samples do not mix properly. Whenever the sample is not mixed properly, in that case, the RBCs get settled down, and we are getting the false positive reaction. So it's better to mix the urine very well and then go for the blood occult reaction. A positive reaction indicates the presence of intact erythrocytes. So whenever we are getting on the pad or the ready-made strips, whenever there is a presence of positive reaction, that the positive reaction may be occur because of the erythrocytes, hemoglobin, myoglobin in the urine, and must be interpreted in conjunction with the urinary sediment finding. So all these things should be considered together. So the microscopic as well as the chemical analysis will be interpreted together. Then hematuria is the most common cause of the positive blood occult results. Prehemoglobin is an uncommon cause in case of the dogs. Generally, myoglobin is found very rarely in case of the dogs. The hematuria can be occur from any lesions along with the genitourinary tract infections that allows entry of the red cells into the urine. So maybe the trauma, inflammation, infection, infarction, neoplasm, calculi, and coagulopathy. In all these conditions, hematuria can be observed. Then hematuria becomes macroscopically apparent more than 0.5 ml of blood mixed with the 1 liter of urine. Whenever the volume of urine is 1 liter, and if the 0.5 ml of blood, the fresh blood is mixed into that, then it can be detectable macroscopically with the naked eyes or on the pad. The deep strip reagent pad method allow detection of the hematuria before it become visible macroscopically. So whenever we are observing urine, whenever we are observing the urine, if we are getting the red urine, before that the strips can give identification of the blood occludes or RBCs or the RBCs into the urine with the help of deep strip. So if you want to find out, want to find out the blood occludes, the deep strip method is a very good method, and we can find out the blood occludes in that. Then cystitis, urethritis, urinary tract infections. Then the cystitis by the idiopathic, usually in case of cats. Then mechanical urolithiasis. So whenever the uroliths are there, this in the bladder, or whenever there is a presence of uroliths, that may interfere with the mucosa of the bladder or the mucosa of the urethra or the renal pelvis. In all these conditions, there is an interaction and there is a leakage or the breakage of some of the capillaries, and that may lead to the blood in the urine, and that can be detected with the different methods that includes strips also. Then genital tract contamination. In case of estrus, whenever there is an animal is in estrus and we are collecting blood, so some of the blood get contaminated to some of the blood or uterine discharge get contaminated to the urine, and there are chances of the false positive reactions. So in case of estrus, that can be observed. Then prostatic diseases, whenever there are chances of the disease of the prostate gland, in that case also the hematuria can be observed. Then uterine diseases, vaginal diseases, and prepucial diseases. So whenever prepucial disease, generally it is observed in case of the venereal granuloma in case of the male dogs or female dogs. Whenever there is presence of such type of infections, there are generally the dribbling of the urine with the color is the red color urine, or hematuria can be or the false hematuria, we can say, can be observed. So just we have to interpret these things along with the microscopic examination. Then renal problems includes nephritis, nephrosis, renal infarcts, then renal pelvis hematomas, benign renal hematuria, renal parasites, generally rarely observed, dictyophyma renal, then systemic coagulopathy and strenuous or the excessive exercise and trauma. So in all these conditions, whenever there is an excessive exercise, there are a little bit change in the hyperactivity or the hyper excitation, and the more filtration rate is there, and in that case there are chances of the some diapedesis of RBC, and finally we are getting RBC into the urine. Now after blood, we can go for the glucose. So again, the strip methods is a better one for the identification of this thing, glucose. Then it is basically based on the oxidase, peroxidase, and chromogen. Whatever the things which has been kept on the strips that combines all these things together. The color reaction corresponds to the quantity of the glucose present in the urine when read at the appropriate time interval. So generally, as we know, the glucose is get metabolized very fastly. So the fresh urine generally can be used for the identification of glucose. The false positive reaction may occur if the color indication or the indicator directly activated. Example, the urine sample is contaminated with the hydrogen peroxides. Whenever there is a contamination of urine with the hydrogen peroxides, there are chances of the false positive reaction or the hypochloride. Whenever the hydrogen peroxide or the hypochloride, when mixed with the urine, there are chances of the false positive reaction. The large amount of ascorbic acid, vitamin C in the urine may lead to the false negative reaction. The presence of formaldehyde or fluorine or the fluoride in urine samples may result in inactivation of the glucose oxidase, and finally we are getting the false negative reaction with the formalin. Then hyperglycemia lead to the glycosuria when the capacity of the proximal tubular cells to reabsorb the filtered load of the glucose has been exceeded. Then renal threshold for the glucose is approximately 180 mg per dl in dogs and 300 mg in cats. Glycosuria without hyperglycemia may occur in some of the cats with the chronic disease, possibly due to the altered proximal renal tubular functions. Glucose, the causes of the glycosuria, the diabetes mellitus, stress, excitement in cats associated with the hyperglycemia, the chronic disease, and related to the kidneys in the some cats associated with the normoglycemia, the administration of glucose containing fluids, and renal tubular disorders. So all these things lead to the glucosuria or the glycosuria in case of the dogs. Now after that, ketones, the ketones in plasma are filtered by the glomeruli and incompletely reabsorbed by the renal tubular cells due to the saturated tubular transport process. For this reason, ketonuria is often proceed detectable ketonemia. So for the detection of ketone bodies, there must be the ketonemia in that particular patient. Ketonuria occurs more readily in young animals, and diabetic animals is the most important cause of the ketonuria in case of the adult dog and cats. So ketonuria is generally observed because of the ketonemia. The false positive reaction can be reportedly rare. Means it is we can say the true chemical reaction. So it is rarely observed in case of the dogs. Although highly pigmented urine may occasionally result in the false positive reaction, the false negative reaction generally not observed in case of the ketones. The this prolonged fasting, starvation, the glycogen storage disease, low carbohydrate diets, then persistent fever, persistent hypoglycemia, the causes of ketonuria, again, the diabetic ketoacidosis, the prolonged fasting, starvation, then glycogen storage disease, low carbohydrate diet, persistent fever, persistent hypoglycemia. So all these factors lead to the ketonuria. So after that ketone, the another chemical that can be detected from the urine, the bilirubin. The bilirubin is derived from the breakdown of the heme by the reticuloendothelial system, that is MPS, mononuclear phagocytic system. Then conjugated or direct reacting bilirubin is water soluble and normally is present in the glomerular filtrate. Unconjugated bilirubin does not passes through the glomerular filtration or capillaries due to its protein binding. So only conjugated bilirubin appears in the urine. So these are the things we should keep in mind. The canine kidney can degrade hemoglobin to bilirubin. The renal threshold for the bilirubin is low in case of dog, and the bilirubin may be detected in the urine before it appears in increase in the serum. In case of the dog, whenever there is a liver disease, whenever there are chances of liver diseases in case of dogs, so generally bilirubin is observed first in the urine, and that can be detected with the regular step methods. Then false negative reaction or artificial or the artificially low reading may occur in urine samples that contains large amount of ascorbic acids or nitrates. So in that case, there are false negative reaction. False positive reaction may be observed in case of whenever there is a large doses of the chlorpromazine has been given to the dogs. Then bilirubinuria occurs in consequences of the primary intrahepatic diseases, but the bilirubinuria associated with the extrahepatic biliary obstructions typically more severe. So these are the some of the factors which can be lead to the bilirubinuria. The causes of bilirubinuria: hemolysis, so autoimmune hemolytic anemia, liver diseases, extrahepatic biliary obstructions, fever, prolonged fasting, and starvation. All these conditions may lead to the bilirubinuria. Now, after that, so all these things will be, you can identify with the help of strips, and here we are not going to use much more things. So simply just take a strips, put into the urine in the test tube or in the container, and just match it with the typical chroma has been given with the specific type of reagent that is available readily available in market. So you can use all these things up to now for the identification of some of the chemicals and the specific gravity of the urine. Now here the actual things can start, what exactly we should go with the urine, because microscopic examination is the most important factor of the identification of urine and the identification of the some of the important diseases for the dog and cats. So the sediment examination is the key role in the urine analysis. So no doubt the all chemicals and maybe the glucose, ketones, then the pH that can be demonstrated very quickly with the strip. But the actual the prognosis of the case and the identification of some of the pathological conditions is based on the presence of the or the examination of sediments only. So the microscopic examination is the most important factor in the urine analysis. So in the sediment examination, we are observing red cells, white cells, epithelial cells, cast, then organisms and crystals. So these are the things we are observing in the under the microscope after the during the sediment examination. Now red cells. So red cells means the RBC. So RBCs can be observed in the urine, and there are the criteria for the giving the units of the RBC into the during the interpretation. So normal voided samples, so or the normal urinating dogs, if we are collecting urine, so they are having or that samples are having 0 to 8 RBC per high power pill. So it's a normal range. Within that, RBC may be observed. 0 to 8 RBCs per high power pill may be observed or in the voided sample. Then whenever we are using catheter, so whenever catheter is we are using, so in that case there are chances of the 0 to 5 RBCs per high power pill. Then whenever we are using the or collecting blood, in that case there are chances of the or the normal range of that is the 0 to 3 RBCs per high power pill. So these are some of the recommended things, but the things can be changed based on the laboratories and whatever the protocols that you are following. Now white cells, the normal white cells ratio, it's approximately we have to find out. So in voided sample 0 to 8 white cells, the catheter again the same thing 0 to 5, and in the cystosynthesis 0 to 3. So all these things can be observed into the urine analysis normally. Now any alteration into that may lead to the change in the high power pill or the number of cells per high power pill, and that are most important for the interpretation of the result. Increased number of white cells in the urine sediment is called as a pyuria, and usually indicates urinary tract infection, inflammation or contamination from the genital tract. So we have to find out from where it exactly come. Then urine samples with the most severe pyuria are usually obtained from the animals with the bacterial urinary tract infections, but sterile pyuria may accompany with the urinary tract disorders including the urolithiasis and neoplasm. Now, whenever there is a neoplasm, definitely we are getting large number of leukocytes, but there is a absence of any bacteria or any infection. So that's why it is called as a sterile one. So whenever the urine samples is sterile, no bacteria is there, but till there is presence of some large number of leukocytes, that indicates urolithiasis and maybe the neoplasm. The clump of white cells often occur with the bacterial urinary tract infection, even when the bacteria are not visible. So careful examination of the space between the clump neutrophils often disclose the bacterial organism. Now, many times we are observing urine under 10x, but I will suggest we should go for the more 10x as well as the oil immersion sometimes for the fresh urine with the cover slip. In that case, we are able to identify some of the bacteria. So I will show the pictures of that same things as we go further. Now epithelial cells. So epithelial cells that arises from the urinary tract infection, urinary tract and the genital tract. So the cells which are larger generally come from the genital tract, and the cells which are coming in the urine and they are smaller, they can come from the kidney. Generally, the smallest cell epithelial cells arise from the kidney. So very small cells they come from kidney, and larger cells they come from the either from the bladder or from the urinary tract, maybe the urethra or maybe the tract or the bladder. The largest non-neoplastic cells are often observed in the urine from the distal urethra, vagina and prepuce. So whenever there is a excess or the larger cells, generally these larger cells come from the prepuce, vagina, urethra and distal part of the urinary tract. But the smaller cells are most important to identify to go for the interpretation of the urine. Now the cells are of squamous type of cell, transitional cells, and cuboidal cells. So here we can see the squamous cells. So squamous cells are the cells which are having the some typical type of pattern. The cells are little bit more larger and having the centrally located nucleus. If you see nucleus very carefully, you can see the cytoplasm of cell is like this, bigger, and the nucleus is at the center. So this is one cell, the cytoplasm is like this and nucleus at the center. So here the cells, you can see the one cell and having the nucleus at the center. But if you see the cell which is present over here, just you can compare the squamous cells, it come from the different parts or the different areas than the kidney. So this cell is arising from the kidney, but whenever the squamous cells are there, the squamous cells can come from the tract. Then cuboidal cells. So cuboidal cells are generally originated from the kidney. So the round type of cells, like they look like cubes, but having the nucleus at the center. So these are the cuboidal cells that can be observed whenever there is a damage to the tubular epithelial cells of the kidney, and such type of cells can be observed in the urine. Now mixed type of cells, here you can see some of the squamous cells and some of the cuboidal cells. So some of the squamous cells, cuboidal cells, they can be observed. So here the cells which is bigger is the squamous cells and smaller is the cuboidal cells. Then some of the immunological reactions that can be observed in the cells. So if you see these cells very carefully, so here you can see some of the globules which are adhere to the surrounding of the cell. So these are nothing but some of the antibodies that has been demonstrated. So these things can be observed in the urine also. Now neoplastic cells, sometimes neoplastic cells, they come into the picture. So how to identify neoplastic cells? The simple thing is that we should use the funda of the nucleus and cytoplasm ratio. Nucleus and cytoplasm ratio. So whenever the nucleus cytoplasm ratio is changed from, whenever it is 1:1, so the size of nucleus is equal to size of cytoplasm. In that case, there are chances of the neoplasia, or that ratio may sometime get widened. So whenever the nucleus size is more and more, in that case, there are chances of some of the neoplastic conditions of the tract or sometime in the kidney. Now cast. So the another factor, and which is most important for the identification of different kinds of the kidney diseases, are the cast. Now cast are the different kinds of the material which can be observed in the urine. So that includes the hyaline cast, epithelial cast, white cell cast, red cell cast, granular cast, waxy cast. So these are the different casts that can be observed into the kidney, into the urine, and those are most important for the identification of the different types of the renal diseases. Now, because the cast are the cells which are produced within the kidney. So whatever we have discussed earlier, there may be the contamination, there may be some preputial things, maybe the epithelial cells come from the bladder, maybe from the urethra. Then the chemicals, they may interfere with the positive, false negative reaction, but there is no false positive or no false negative reaction for the cast. So the cast identification is the most crucial part of the urine analysis, and depending upon cast, because the cast, they are originated from the tubules or originated from the nephrons, and they are the very good indicator of the diseases of the kidney. So the hyaline cast, epithelial cast, then the white cell cast, then red cell cast, granular cast, and waxy cast. So these are the things generally we are having the demonstration, these things after the during the sedimentation examination, and they are having their own interpretation, and which is most important for the demonstration of the kidney diseases in the dog and cats. Now, how the casts are developed? So the simple thing is that the cast is nothing but the shaded type of cells from the tubules. So if you see this typical river of the tubules, so epithelial cast having the cells which get shaded. So generally the single cell is indication of the, it may be regular wearing tearing procedure, but whenever the casts are present in the urine, it is an indication of the much more damage to the tubular epithelial cells, or the renal or the intrarenal damage to the kidney. Now epithelial cell cast. So the cells get shaded from the tubules, then they combine together, and as they progresses towards the end of the tubules, there may be the alteration into that epithelial cast, and that alterations and its morphology, then its presence will give a typical idea about the different kinds of renal diseases. Now here the in all-in-one had been shown over here. So epithelial cast, then the granular cast, then coarse granular cast, fine granular cast, and waxy cast. So the whatever the nucleus are there, so the cast which are developed because of the nucleus. So nucleus combines together, they adhere together with the help of some proteins. These proteins are generally formed with the microtubules which are present in the tubular epithelial cells. These proteins are called as the Tam-Horsfall mucoproteins. So THM we can call that the Tam-Horsfall proteins, the Tam-Horsfall mucoproteins. They are liberated from the tubular epithelial cells. They are continuously liberating into the urine, and because of that, whenever there is a damage to the tubular epithelial cells, and whenever there is a shedding or the sloughing of tubular epithelial cells, they all these cells combine together and they form a small a colony type of things, or the a bunch of cells together, and they are bounded by the proteins that is called as the Tam-Horsfall mucoproteins. This Tam-Horsfall mucoproteins get precipitate, and the all cellular details, or the all cellular cells get bind together, and slowly they can progress towards the end of the tubules. Now as the time progresses, there are changes into the epithelial cells. The epithelial cells may converted into you can see the mixed type of cast. So mixed type of cast means there is a granular cast plus a granular cast plus epithelial cast together. Now if the epithelial cast remain for a longer period, that will convert to the granular cast. Then later on, the granular cast will be converted into coarse granular cast, and again it will convert into the fine granular, and later on it may convert into the waxy cast. So each and every cast in the urine is having its own significant value for the interpretation of the urine. Now here in acute nephritis, now if you see the previous picture and the next picture, so here you can see the tubules are become empty. So means that indicate whenever there is a damage, or whenever there is an inflammatory reaction that has been observed into the tubules, there is a sloughing of the epithelial cells from the tubules. So whatever the tubules you are observing, these tubules are empty one, and there is a sloughing of the epithelial cells from the tubules. They combine together and they form a cast. So that cast can be identified in the urine. Now in case of chronic renal failure, you can see grossly the kidney will be look granular. So whenever you go for the identification of the kidney by the USG, whenever you go for the sonography of the kidney, you can see the size of kidney gets shrunken. There is no smooth surface, and you can see the granular type of reaction can be observed, and this is the typical observation in case of the chronic renal failure. Now the histologically you can see the interstitial nephritis can be observed, and the most prominent areas will have the connective tissue proliferation and the presence of the more leukocytes into the interstitial space, and more connective tissue can be observed, and sometimes there is a presence of sclerosis of the Bowman's capsule. So whenever there is a excess of antigen antibody reactions, long-standing fever, long-standing inflammatory conditions, then any antigenic reaction, the protein diet, in all these conditions the kidney may get affected, and ultimate result is that the Bowman's capsule filtration is get affected, and the actual function of the kidney is get damaged. So in case of CRF, you can get typical type of the chronic renal failure and the typical interstitial type of nephritis. Now sometimes we are getting the membranous type of or the sclerosis type of nephritis. So the Bowman's capsule is get covered with the membranous or the scleral type of things. It get deposited. So that is nothing but the deposition of the antigen antibody complexes. They get deposited, and ultimately the amyloid type of or amorphous type of material can be observed in the kidney. This is again this another picture of the interstitial nephritis. Now we can start with the different cast, their formation and their interpretation. Now, TAM Hirschsprung mucoprotein THM serve as a matrix. So TAM Hirschsprung protein serve as a matrix. So the matrix for the formation of most of the cast in human urine, and the same thing is applicable over in case of the animals. So the TAM Hirschsprung protein is liberated from the tubular epithelial cells or the brush borders, whatever the brush borders are there on the mucosa of the tubules. In that case, there is a release of TAM Hirschsprung protein mucoproteins regularly. So it can give some smoothness to the tubular epithelial cells. And one thing all of us might have observed, though the animal is normal, till there is a presence of some fraud to the urine. So generally, we are saying that there is no protein, but the TAM Hirschsprung protein or the very low quantity, that is the 20 microgram per liter, 20 mcg, not mg, 20 mcg protein per liter can be voided daily through the urine. 20 microgram of urine per liter can be observed, and that may lead to the formation of prod in the normal animals. So the TAM Hirschsprung protein or the mucoprotein is responsible for the giving the smoothness to the urinary tract, also not tract, it is a nephron or the mucosa of nephron, we can say. And the TAM Hirschsprung protein is serve as a matrix for the formation of the cast in the human as well as in the animals. Now, TAM Hirschsprung mucoprotein secreted in the small quantities by the normal tubules. So it is normally tubules are produced the TAM Hirschsprung protein from the brush borders of the epithelial cells in the loop of Henle distal tubules and the collecting tubules, and it is then locations the most of the cast. So the we can identify the tubular cast which are located in which part of the kidney. So based on the microscopic examination, we can say this cast is present in a specific area of the kidney. The precipitation of TAM Hirschsprung protein mucoprotein is the initial event in the formation of cast. So this protein, it generally get precipitated. So it get precipitated with the so many factors. So it may be the change in pH of the urine. It may be because of the hypoxia of the kidney and the change alteration in the pH of the urine. So all these factors may lead to the precipitation of THM. Now, other materials, example, cellular debris, brush borders, the intracellular organelles, serum proteins present within the tubular lumen at the time of matrix precipitation will trap by the THM. So, during the process of the wearing, tearing, or the whenever there is hypoxia or whenever there is a damage to the kidney or the nephrons, there is a slipping of some of the cells. There may be the leakage of some of the cellular organelles. There may be the leakage or there may be the rupture of the cytoplasm, then the removal of nucleus. Then all these things will be trapped by the THM. So you can see, if you see the first picture, again I will show this one. So whenever there is damage, there is a release of these cell organelles, and these cell organelles will be trapped by the THM, and that THM will form a matrix to the cellular elements and convert into the cast. The cast are formed with the help of the precipitation of the THM. Anything that favors secretion or precipitation of TAM Hirschsprung proteins and mucoproteins will promote the cast formation. So anything may be the mild irritant to the moderate irritant or the severe inflammatory reaction. So any kind of mild to moderate or severe inflammatory reaction may lead to the precipitation or the inflammation into the tract, and that lead to the precipitation of TAM Hirschsprung mucoproteins. Then TAM Hirschsprung mucoproteins precipitate more readily in the urine that is acidic and highly concentrated, and during times of a low tubular rate flow. Now, whenever there is a flow of urine is less, then whenever there is a acidic pH and whenever there is a concentrated type of urine, in all these conditions, there is a excess chances or the more chances of the precipitation of THM can be observed. The presence of normal serum proteins, hemoglobin, myoglobin in tubular fluids favors the precipitation of the TAM horse pulp mucoprotein. So whenever the myoglobin urea is there, hemoglobin urea is there, or whenever the more protein is there in the tubules, in that case there are chances of the precipitation of THM. Very large cast generally observed in the collecting duct or pathologically dilated portion of the distal tubules. Now, whenever there is a obstruction to the flow of urine, in that case, there are chances of dilatation of tubules, and this dilatation, after that dilatation, the cast get widened or it get flushed. And in such cases, whenever very large cast can be seen in the urine, so that is indication of the either this cast can be come from the collecting tubules or the collecting duct, or sometimes it may come from the dilated portion of the tubules. Very thin cast, generally these thin cast can be come from the loop of Henle, and sometimes it may be due to the over compress or because of the interstitial nephritis or the edema of the kidney. So whenever the tubules are there, tubules get compressed and the cast is also get compressed. So very thin cast present in the urine is an indication of the compression of the cast, and as well as this cast can be present or they can be come from the such portion of the nephron which is having the a narrow type of lumen, narrow lumen, and generally only the loop of Henle is having the narrow lumen. So whenever we are getting the thin cast, it is an indication of the, it can either from the loop of Henle or it may be because of the over compression from the interstitial spaces or the spaces outside the tubules. So maybe because of the edema or interstitial type of infiltrate, maybe the interstitial nephritis, interstitial infiltration of the antigen antibody complexes or the leukocytes. So all these things may lead to the thinning of the cast. So very large cast can become from the distal portion, either from the collecting duct or it may come from the dilated tubules, and thin cast from the because of the compression and the loop of Henle. Now here I can show one cast which can come from. So here we can see, if you see such type of cast, this cast indicates this cast is present at the terminal portion of the loop of Henle. So this portion is get lodged into the loop of Henle, and this portion is into the distal convoluted tubules. So the this type of cast can be indication of the a cast at the caudal portion of the loop of Henle. Now mixed type of cells or the mixed type of cast, so such type of pictures can be observed many times in the urine sedimentation. So you can see so many cells come together. Some of the leukocytes, some of the cuboidal epithelial cells, they are present into the urinary sediments. So this is a clump of cells, and if you see very carefully, you can see the, as a rule we have discussed, we can, if you want to demonstrate the bacteria, you can demonstrate the bacteria in between the cells or in between the gap of the cells. If you see the gap between the two cells, you can see the bacteria, they can present in the gap of the cells. Generally, we are not getting bacteria within the cells or within the clumps, but we can see the bacteria, they can be present, because though we are observing this portion is empty, but it is actually not empty space. This is the space is occupied by the mucoproteins or the THMs. So in that THM, we can get this some of the bacteria. If you see very carefully, this rod type of bacteria can be observed. I will show some of the slides. In that also, we can see the bacteria. Now here we can see the epithelial cells, then the leukocytes. All these are the leukocytes. Then we can see the bacteria. So here again, you can see the bacteria. So bacteria can be demonstrated between the cells. So again, the mixed type of cells can be observed. Here again the same thing, the epithelial cells are there. Then you can see the clumps. These are the amorphous bodies. So that is indication of the disintegration of the epithelial cells and disintegration of the some of the proteinous portion. So these are the three type of cells can be observed. So here you can see the some of the bacteria. Now starting with the cast. So hyaline cast. The hyaline cast are the pure protein precipitation. So here there is no involvement of any cellular material, no any nucleus, no any cell organelles. So only hyaline cast indicates there is a mild type of irritation to the kidney tubules. Whenever the hyaline cast are present into the urine, it is an indication of the mild irritant or the mild inflammatory reaction takes place into the kidney. So hyaline cast are the pure protein precipitation of the time horsepower mucoproteins and a small amount of the albumin. So albumin and time horsepower mucoproteins, they combine together and they form a hyaline cast. Then animal with proteinuria of the renal origin, example glomerulonephritis, glomeruloamyloidosis, and frequently form hyaline cast. So hyaline cast also form during the process that change glomerular hemodynamics. Whenever there is a retention of blood for a longer period, so it may be because of the congestive condition of the kidney. In that case, there are chances of the development of this type of protein urea and protein cast, specifically the cast which is having only the a framework and only the mucoprotein is available with the albumin, but no cellular elements can be trapped into that cast. So here you can see microscopically, you can see the tubules are there, and the hyaline cast is without any nucleus. You can see the straight one, and no nucleus is involved over here. Now actually you can see the cast, it look like this. So hyaline cast is a transparent. You can see the hyaline cast is always transparent. There is no involvement of any nucleus. So whatever things you are observing, it is a artifact which has come from the other cellular debris. So hyaline cast is a little bit larger in size, and it is a transparent and very fragile. So I will suggest, when we want to demonstrate the hyaline cast, we should go for the immediate examination of the urine, because after some time this cast is get disintegrated. So after storage, the hyaline cast disintegrated. So the best time is to collect the urine and examine the urine for the demonstration of the hyaline cast. So hyaline cast is the most crucial type of early tubular damage, and the mild type of inflammatory reaction takes place into the tubular epithelial cells or the nephrons. Now the next cast is the epithelial cast. Epithelial cast is a renal epithelial cast, larger than the white cells and contains a large round central nucleus. They are easy to identify whenever there is a all cellular details are present in a good stage, and they are lined by the mucoproteins like tam horsepower proteins, and differentiated from the white cell cast when the renal epithelial cells have undergo degeneration. Now, epithelial cells cast are formed when renal tubular epithelial slough. Whenever there is a sloughing of tubular epithelial cells are observed, in that case, the epithelial casts are observed. So here you can see the nucleated cells, then the W means WBC, and N then nucleated epithelial cells. You can see, compare the size of the epithelial cells and size of the WBC. So the size of WBC is smaller and the size of epithelial cells is much more. The presence of epithelial cast in the urine sediment indicates active renal tubular necrosis. Now, why this is most important to demonstrate the epithelial cast. So once we get the epithelial cast, it is an indication of the necrosis of the tubules, damage of the tubular epithelial cells, and once there is damage to the tubular epithelial cells, that is lead to the detachment of the tubules, and there is a formation of the cast. So there is a sloughing of nucleus. Once there is sloughing of nucleus, then tam horsepower mucoprotein is ready for the formation of matrix. So cells get sloughed, then they trap by the tam horsepower mucoproteins, and they form a cylindrical or the elongated type of material, and that is called as a epithelial cast. These casts are having its nucleus. I will come to these slides later on. Now, the findings of the epithelial cast in the urine sediment usually suggest the presence of severe intrarenal diseases and associated with the acute tubular injury, and often associated with the nephrotoxicity and ischemia. Whenever there is a ischemia, so as everybody knows that ischemia means loss of local blood to that particular portion, and local ischemia, nephrotoxicity, then intrarenal diseases and acute tubular injury. All these conditions may lead to the presence of epithelial cast into the urine. Epithelial cell cast also may be observed during the episodes of the renal infection Then acute nephritis, say for example, leptospirosis and pyelonephritis. Whenever there is an inflammatory reaction caused by the leptospira and pyelonephritis by the so many bacteria may lead to the presence of epithelial cast. Okay, I will show picture later on. Now, white cell cast, white blood cast, the pus cast, we can say, they consist of the predominantly neutrophils. The mixture of the neutrophils predominantly and readily identified with the cellular details. So, if we go for the staining of the sediment, then we can demonstrate the neutrophils very specifically. Then mucus or the fibrin strands can be facilitate the such white cell aggregates. In case of dog and cat, white cells cast commonly associated with the acute bacterial pyelonephritis. Whenever there is a bacterial type of pyelonephritis, so in that case, there are chances of the presence of large number of white cell cast. Then other form of interstitial nephritis, example leptospirosis, allergic interstitial nephritis, occasional result of the excretion of the white cell cast. Then cast containing the white cells and epithelial cells may be seen in the patient with the tubular necrosis. Now, whenever there is a combination of the two pathology together, in that case also we are getting the white cell cast. So here you can see demonstrate the neutrophils. So these are the stain type of sediment. So this after staining we can see the different cellular details of the neutrophils. Then you can see the some of the bacteria. So in case of pyelonephritis, we can see the different types of leukocytes and the bacteria also. Now red cell cast. So this red cell cast can be observed in the animals, in dogs, but these findings are very rarely observed. This cast can be observed when red cells aggregation within the tubular lumen and their presence indicates intrarenal bleeding. So whenever there is an intrarenal bleeding and whenever we are getting the RBC cast or the red cell cast, that is indication of the intrarenal bleeding. A red cell cast may be found in the cast containing the renal tubular epithelial cells and white cells referred as a mixed cast. So many times the red cell cast and the white cell cast come together. That is called as a mixed type of cast. Now the granular cast in the they are present or they represent the particular matter arising from the renal tubular necrosis. Whenever there is a tubular necrosis and degeneration, the granular cast can be present. A cellular degeneration can occur within the renal tubules, resulting in initial as a coarse granular, and later on this coarse granular cast will converted into the fine granular cast. So that is nothing but the changes that observed in the cell organelles and the nucleus of the particular cells, and as disintegration observed, the coarse granular cast will converted into the fine granular cast. So differentiation between the coarse and finely granular cast is of little significance because the granular cast indicates the tubular necrosis and degeneration. So if we are getting coarse and fine granular cast, the both are having the same significant value. So both indicates there is a presence of cellular necrosis and degeneration of the tubular epithelial cells. The presence of granular cast in the urine sediment usually indicates some underlying tubular and interstitial type of disorders, occasionally proteinuria and glomerular of the glomerular origin. Then lipid cast are the type of coarsely granular cast containing lipids droplets that may be seen in patient with the nephrotic syndrome or the diabetes mellitus. Whenever the dogs are having the diabetes mellitus and we are observing the granular cast, and with the granular cast along with some fat droplets, so that is the indication of the diabetes mellitus and the nephrotic syndrome observed. Means once there is a nephrotic syndrome, we are observing the granular cast and droplets of fats into that particular cast. Lipid droplets accumulated into the cast as a result of the lipid degeneration of the cell. So it's generally the enzymatic reaction that can be takes place within the shaded epithelial cells, and that will lead to the different observation into the urine sediment. Now here you can see the granular cast. Granular cast are the elongated one, and as name indicates, they look like a granules. So they are limited by the mucoproteins. They are bound by the mucoproteins, and within the mucoproteins you can see the small granules. They are present throughout that particular bundle like things or the bullet like things. Now waxy cast. The waxy cast are thought to be represent the final stage of the granular cast degeneration. So whatever the granular cast which are observed. So first epithelial casts are observed, they converted into the granular cast, and once the granular cast undergo the degeneration, they lead to the formation of waxy cast. So the waxy cast is a indication of the last stage of degradation of the granular cast. They are easy to identify because they are high reproductive index, so they can easily demonstrated. So in like a highline cast, we need to go for the special type of examination or the special adjustment to the microscope, then we can demonstrate the highline cast. But in case of the waxy cast, as it is having the more refractive index, in that case we are easily identify the waxy cast. It's a homogeneous, translucent, and translucent in appearance. Waxy cast are the most stable type of cast. So once the waxy cast are there, they will remain, or the it is indication of the stable type of cast. They are stable in dilute or alkaline urine. In both the urine, they can be present, but their brightness often result in the blunt end and the cracks. Sometimes there are chances of the cracks can be developed at the ends of the waxy cast. The casts that are highly convoluted and likely to be waxy cast. So the cast which are having the we can say the convoluted or the tortoise or the hazy or zigzag. So zigzag type of cast are the waxy cast. So here you can see the cadine urine sediments having the waxy cast. So definitely we can see the waxy or the fat globule like structures, they can be present over here in case of waxy cast. Now the canine urine sediment containing the granular cast and waxy cast together. So here you can see the granular cast over here and the waxy cast has been developed over here. So this is typical type of granules. You can see the fat globules or the waxy type of reaction. So typical type of waxy reaction, it has been demonstrated by the Sudan strain, and it look black in color. The waxy cast are usually associated with the chronic renal diseases. Once we are observing the waxy cast in the urine, it is an indication of the chronic renal diseases, and most of the times it is called as a renal failure cast. So whenever we are getting the waxy cast into the urine sediment, it is an indication of the renal failure cast, like the heart failure cells into the sputum. In the same fashion, it is also called as the renal failure cast whenever the waxy cast are present in the urine sediment. Now the broadcast, some casts are the larger. The broadcast are often observed in the urine. It is generally originated from the collecting duct. So larger portion of the nephrons or the collecting duct is involved in the formation of this broadcast. The broadcasts are often waxy in nature due to the associated with the intrarenal stasis. So whenever there is the intrarenal stasis, this type of cast, whenever they are present, again that indicates the intrarenal stasis. But any kind of cast can be classified as a broadcast. Then the presence of large number of broadcasts suggests the severe renal disease, but may indicate the recovery as a oliguria is converted into the diuresis in patient with the acute renal failure. Now, sometimes it is observed that whenever the patient is having the acute renal failure, and we are treating the such cases by giving the diuretics and with the typical type of the intravenous fluids, so that such type of cast sometimes get flushed into the collecting duct, and if we are observing that type of cast, so it may indicate the it's a recovery from the oliguria, and it will be the secondary effect of the or the recovery effect of the renal failure. So the broadcast will be one of the postulations. So broadcast may be considered as sometime the recovery stage of the acute renal failure. Then crystals. The crystals can be observed into the urine. Maybe different types of crystals are there, and the presence of crystals may be interfere because of the precursors. Then urine pH, the alkaline pH, acidic pH can interfere with the demonstration of the crystals. Then total urine solutes, that is urine and specific gravity. So again, the number of solutes they are mixed with the urine, they can find or they can interfere with the crystal formation. So whenever the urine is formed, all the minerals or the crystals, they are in the elemental form or ionic form, and after storage they can condense together, and the single crystals generally not having this much more meaning for the demonstration. And it is also observed that after storage of the urine for the a longer period in the refrigeration, so in that case there are chances of the formation of the crystals into the urine because of the condensation of the molecules or the condensation of the ions. Now, the whenever crystals are there, we have to correlate the crystals along with the different kind of conditions like the cystitis. So whenever the crystals are there, we should see the blood occlusion is there, then there is a presence of the leukocytes, and collectively if the all these things come together, and we should go for some of the USG, and in that case we can confirm that this is a case of the urolithiasis or the stones in the either in the bladder or in the kidneys. So one of the common condition of the formation of crystalluria is the cystitis because of the urolithiasis. Now, crystalluria is often present in the urine that has been kept in a refrigerator for a longer period and may not observe in the same urine, the sample which has been analyzed immediately after collection. So, crystalluria in urine that has been refrigerated has no any significance. So if we are keeping urine in the fridge and then observing the large number of crystals, that they doesn't have any meaning or they doesn't have any pathological interpretations. The steroid, amorphous phosphate and oxalate are the examples of the crystals. Then uric acid, calcium oxalate and cysteine type of crystals, they are found in the acidic urine, whereas steroid, then triple phosphate, calcium phosphate, then calcium carbonate, amorphous phosphate, ammonium biurate are the typically observed in the alkaline urine. So here I will show some of the pictures of the crystals. So here is a calcium oxalate monohydrate. Then you can see the another picture of the sediment of the apple form of ammonium acid urate crystals. Then this is another picture of the sulfathiazine trimethoprim crystals whenever it has been given orally to the dogs. Then this is a cysteine crystal, sorry, leucine crystal. Leucine crystals can be observed. Then these are the crystals of magnesium ammonium phosphate, magnesium ammonium phosphates. Then the amorphous xanthine type of crystals, they can be observed in the some of the dogs. Then calcium oxalate crystals may also be observed in the urine of the animal. In case of urolithiasis, the presence of cysteine crystals in urine in dogs and cats is abnormal and suggestive of the cystiuria or the crystalluria. Then bacterial staining. So after the epithelial cells cast, then the cells, the bacteria, we can demonstrate the bacteria with the help of gram staining, then the Fontana staining and cotton staining. So cotton staining can be used for the fungus. Then Fontana staining, so as we are dealing with the dogs, so dogs are most commonly susceptible to this one infection that is called as a leptospira. So in case of leptospira, we should go for the Fontana staining of the urine sediment. So simply we can go for the urine sedimentation, and after sedimentation we can go for the we can go for the preparation of the slides, and that slides has been stained with the Fontana stain, and after that we can able to identify the leptospira organism. Then sometimes the rarely things that parasites or parasitic eggs can be observed, but these are the rare things can be observed. But most of the times the contamination of the ova or eggs from the intestinal parasites and generally observed in case of the female dogs. So that has been observed in case of the female dogs, because if we are not taking proper care while while collecting the urine, so there is a fecal contamination of the vulval lips, and that vulval lips again contaminate the urine, and that interfere with our routine examination as well as the microscopic examination of the urine. Okay, so here is from my side. So I will be happy to give answer to questions if you have. Otherwise, you can contact me on the email, so I can give all questions or the answers to you on email. Okay, thank you very much. So here,
Thank you.
yeah.
Thank you, Dr. Suryavanshi. There are two questions. Please go through there in the question answer box.
Stop sharing. No.
You can stop sharing your screen.
Yeah. Okay. Okay, here one question is there. Cystosynthesis is the best method of the urine sample examination. Can we diagnose the myeloma by the chemical examination of the urine? Yes, we can identify the myeloma, no problem in that. So here we can go for the specific type of protein estimation from the kidney or the urine examination. And if the PET is what we say, if cooperative, then we can go for the cystosynthesis. Otherwise, we can go for the general anesthesia or the sedation and then collect the urine. Then next question, sometimes physical examination of urine shows good number of pus cells, but the antibiotic sensitivity test shows no growth in sterile sample. Okay, why it's so? Now the you can see the bacteria, you can see only the pus cells, but as we discussed earlier, the always the pus cell is not indication of the presence of bacterial infection. So if we are getting pus cells during the physical examination or the sedimentation examination, and as you are sending sample to the sensitivity, you are not getting the sensitivity results. So there are so many chances of the use of previous antibiotics. If you are using antibiotics previously, before giving any urine sample to the laboratory, in that case, there are chances of the sterile urine and you are not getting any bacterial growth into the laboratory. One thing. Then second thing is that if the a sterile type of infection is there or the sterile type of inflammatory reaction is there in the intrarenal areas, in that case also inflammatory reaction can be observed, and you are getting large number of neutrophils into the or the pus cells into the sediment, but you are not getting the bacterial load into that. This is another things. If you have the cystitis by the any uroliths, then if the neoplasms are there, in that condition also we are not getting bacterial growth or the sensitivity. So the for the sensitivity, it is most essential that we should send sample without any antibiotic. And as we are suspecting, if the bacterial infection is there, definitely we are getting the sensitivity reaction for that. But the stones, then the tumors, then the intrarenal sterile type of inflammations that lead to the this type of reaction. Okay, so these are the two questions.
Thank you, sir. It was a very informative session.
Yeah.
It's a very lengthy topic, so it's getting interesting. Very thank you for this.
Yeah.
Next Sunday we'll be again joining you.
Yes.
Thank you very much.
Okay, thank you. Thank you.